Swayam Prabha. Digital India. Educated India.
Dear students, so today I will start again the tuning of electrocatalytic activities of electrodes. So last few classes I taught that we can tune the electrocatalytic activities with different chemical treatment, electrochemical treatment. Today again I will continue the similar kind of tuning phenomena, but let's come how we can tune some other treatment method. And definitely this is a very interesting topic, as I told. The tuning method we can use for high catalytic activity as well as low catalytic activity, right? So maybe you have to understand why you need and how you can apply those technology for tuning the catalytic activities and what's the reason. Let's come one by one. So mainly then the basic topic, these lectures we cover the tuning the activities and dependence of these activities on pre-treatment and aging. As I told last class also, this is kind of pre-treatment, right? So when we clean the electrode surface, we are removing the impurities. So now these few classes I will take basic fundamental things. So how we can work on basic area on electrode surface area now. So I already taught you like development of biosensor. Now coming back again to the development part, then again we will go to the advanced level. So like we will go up and down, right? Let's come again to the surface modifications. So main keywords for this, that's why pre-treatment, like as I told, this is just enhancement tuning method. And tuning means not only the enhancement, it also you may need deactivations of the electrode surface activity, right? And how this after pre-treatment, as I told, that after sodium borehydride treatment you may get the higher electrocatalytic activity, or after anodic treatment you may get the higher electrocatalytic activity. But when you apply the aging effect, aging means when you store the electrode for longer time in laboratory environment, or even in the vacuum conditions or in the solutions medium, how it will impact on electrocatalytic activity, right? This is also very important phenomenon for storing, because sometimes we need like how long you can store your sensor for checking of the result. So you should know the storage conditions, and still if you are following all the storage conditions, but you may face like deactivations of the result. That's why maybe your signals may go down. What's the reason? That's why you should understand. So one reason that I told you, that the aging effect. Let's come this all the aging factors again, like as I told in the last class, like citrate, ascorbate, sodium borehydride, electrode deposition, all the methods we can use for gold nanoparticle synthesis. Now if we try like formic acid, like glucose oxidation or hydrogen peroxide oxidations, you may get the very fast electron transfer rate, but when you keep for aging, then activation can be decreased. But again, how we can go back again, when you can go very simple treatment like sodium borehydride, maybe after a year after storage of your electrode, or you saw that electrode activity is not so good, then what you have to do, you have to go for the sodium borehydride treatment. I am telling not after biosensor formation, I am telling this on basic sensor surface. Let's come the tuning. Today I will cover all the tuning method. Again some new topic of the tuning. Say we can tune the electrocatalytic activity based on different sizes. Size of the nanoparticle also can impact on the electrocatalytic activity. Sometimes different size of the nanoparticle has the different activity. Also like sometimes like spherical size, sometimes rod size, ribbon size, different size, they have the different surface area, different activity. So based on this we may control your same compositions but different size, your electrode surface activity can be changed, because your sensor surface, because you are modifying maybe sometimes spherical size or sometimes like this, like tube size, the activity can be changed. Also that is called the morphology, that the physical tube. At size means like smaller, bigger, and sometimes we are saying the composition. Compositions mean like you may use some hybrid or maybe core cell or maybe alloy, not the pure gold. Maybe you can iron and gold compositions, or maybe some core cell type. So inside you have like silver, and outside you may have the gold. This is called the core cell type. This core cell type also nanometer has a different activity, that also you can tune. Okay, so this all the things you should know, like how you can tune. So that's why I'm saying that tuning the catalytic activity, they are very much related, size, morphology and composition. Now let's come a very basic concept that I'm going to tell you, like chemical treatment. I already taught you, like sodium borohydride treatment 1. So if you have metal based nanoparticles, not only the nanoparticles, today I will show you if you have the electrode itself, so you can go for the treatment. Sometimes the mechanical treatment. What is the mechanical treatment? Like electrode polishing, electrode polishing. So from the name of the polishing you understand, right? So you may have a pad and it will contain some alumina, slurry, alumina. So those alumina you can use for polishing your kind of disc electrode. Just one thing you should remember, which electrode you should go for the polishing. So if you have the pure gold electrode, kind of the disc electrode, the gold disc electrode available is the pure gold, that you can go for the polishing. You can polish here. Generally we are polishing something like this, we are making 8 and we can polish, okay, like this way. You can polish for 1 minute. You can put the alumina powder here, alumina, different sizes alumina powder available. You can put the alumina powder, and then the disc electrode, this is the disc electrode, something like this, you can put here, and then you can polish it on here, on this pad. Then after polishing you have to wash it with the DI water, and then in a small beaker take few ml DI water and keep your disc electrode and sonicate. You have to sonicate it, sonicate it for like maybe 15 minutes. So if you have any other alumina powder here, if you attach, they will be removed from the surface. Okay, and also after the mechanical, this is called the mechanical polishing, electrode polishing, this is called mechanical. So this is mechanical treatment or mechanical polishing. Okay, this polishing will definitely help to remove all the contaminant you have on the electrode surface, because it's a mechanical. So you may think like after the polishing, after the DI water washing and then sonication for 15 minutes, if still some alumina powder there, then you can go for the another treatment after the polishings. This one maybe you can take a electrochemical cell, fill it with, after the polishing, and your disc electrode, this is the gold disc electrode, right, AU disc electrode. Okay, this is gold disc electrode, then put here a reference electrode and put here counter electrode, then add this all the 3 electrodes with the potentiostat, and then you can go for the potential cycling, which potential cycle you may use, like minus 0.2 to 1.4 volt. So this potential cycle, it is the gold disc electrode. If you go for the potential cycle for 20 times, something like this, you may see this kind of cycling volt, oxidations of gold, reductions of gold, oxidations of gold, reductions of gold, something like this. So like this way you can make, after the mechanical you can go for electrochemical polishing again. So almost your surface will be clean and this surface will be highly activated than your before your electrode that you received from any company or from any other source, your vendor. So you should go always this kind of mechanical polishing treatment so that you can remove all the contaminant. So this is also kind of tuning of electrocatalytic activity. So if you polish it, then you may get, so if you check like before polishings, if you check the like formic acid oxidations, before polishing you may get something like this cyclic voltammogram for formic acid oxidation. After polishings you may get something like this. So why improve? Because it removed all the contaminant, also at the same time it enhanced the catalytic activity. So this is another treatment, but you should keep in mind, maybe after polishings you may need, maybe suppose you clean today and you want to store, you have to store it, because maybe today you cannot fabricate your sensor surface, gold surface, within today maybe you are not able to fabricate your biosensor on that surface. So which conditions you will store this electrode? So that I am going to tell you now. But if you store it for a quite longer time, so you should check the activity, basic surface activity, then you have to check. Why? Because there may be aging effect. So aging effect also can cause the decrease of the electrocatalytic activity. So it can cause the reproducibility problem, that's why. Clear? So what you will do then, you have to store it first in the proper conditions. Which conditions? Maybe you should avoid the contaminant, or even you may store this one in vacuum or in the solution conditions, maybe in the DI water or maybe like very pure water you have to use and store this kind of disc electrode. I mean, this surface can be dipped and you can store for the longer time, but still you may face some amount of deactivation if you store for quite longer time. So that is called the aging effect. Okay, so that you have to check. So enhancement or faster electron transfer, whatever you are facing, that just after the pre-treatment or after the mechanical polishings, and this electron transfer can be slowed down. Okay, that you should remember. So electrocatalytic deactivations by aging, this is a natural phenomena. So high electrocatalytic activity that you are getting or you are obtaining just after the synthesis. So why I am saying the synthesis, because you know last time I taught you, like if you go for the nanomaterial synthesis, just for citrate or maybe ascorbate method or by any kind of reductions method from the gold salt, then you are getting gold nanomaterial. But after storage for some long time you are getting the lower activity. So that's why just after the synthesis or after treatment, treatment means it can be the mechanical polishing, mechanical polishing, or it can be sodium borohydride treatment. Sodium borohydride treatment, it is called chemical treatment, right? Chemical treatment. So is this normal one? This is the questions. After this treatment, after the synthesis, if we get the deactivation, what's the factor? So if the electrocatalytic activity change with time, so you have to take care of this. So you have to properly investigate this phenomena. So activities that we are measuring, if they are not reproducible every day with time to time, then there is definitely some cause. So we cannot store for the longer time. So what's the meaning of the degree of reproducibility of the electrocatalytic activities after the pre-treatment and synthesis if we store for the longer time? So let's see this all the tuning activities and their aging effect. Today I will teach you one more factor of the tuning, that is phantom treatment. This is again some tuning, and we will check their storage effect for this catalytic activity. As I told, like just after mechanical polishing, right? So if you have the paired alumina, so if you polishing like it, then you can see the catalytic activity. As I told, if you check like hydrogen peroxide oxidations or glucose oxidations, as I told, you get the very high activity, right, like this. But before the polishing you may get like this activity. This is before polishing, this is after polishing, after polishing. Now you have to consider to development some biosensor, you don't need that much activity. I mean, even your basic surface, so that you may get very high background current, right? Just after polishing or just after sodium borate treatment, if you get very high activity, it may cause high background current. So let's tune the activity in such a way so that you want to get a moderate activity, means in between. For that, you may go a treatment that is called phantom treatment. So you understand the story, right? So sometime you may need very high activity, sometime you may need moderate activity. Why? To avoid the side reactions or background current you may need to decrease. You don't need very high background current, so you may need the moderate activity. So you need to tune the activity. That's why you can use phantom treatment. What is this phantom? Phantom, that this is a chemical treatment, chemical compositions that I am going to tell you the mixture. So first let's tell you that if you see this image, see this kind of, you can see valley and hill and valley type of the structure. This is the AFM structures of the gold surface just after the polishing. Now this surface is not the comfort, I mean it feels some strain. I told you, in the last class, or because of the structural reconstructions, the surface activity will be very high. Now you want to make this surface maybe some smoother. So this kind of phantom treatment, this is just chemical, but this chemical combination I will let you know, it can smooth the surface. See, it was hill and valley type and you are getting very high activity. Now if you go for the phantom treatment, your surface also becomes smooth. This is again, you have to take the AFM image, atomic force micrograph image. You can see the surface smoothness. This is called RMS, like root mean square value you can determine from the AFM. I am going to show you more surface images. Next slide. This RMS value we are going to detect. If you detect, here the RMS value is very high and here you will see the very low, almost becomes smooth, and you will get the lower activity. Depend on degree of this treatment, like how long you want, maybe 15-minute treatment or maybe 30-minute treatment. Depend on this treatment time, you can change the surface roughness, this RMS value, root mean square value, surface roughness you can change, and you may get different activity. Clear? And like this way you can tune the activity. So this kind of phenomena can be tried with other materials also. So you have the huge scope of the research itself, not only the gold, you can try also with some platinum electrode also. Why only gold? So I described here gold. You can try with other also platinum electrodes or some other electrode also. So this is also kind of pre-treatment we can try, not only phantom, like other pre-treatment you can try, and you can check their aging effect. Now I am going to show you all the respective data. So we can choose gold, platinum just for example, and we can go for the sodium borate treatment, mechanical polishings, you can go for the cathodic treatment. So another treatment just I am going to introduce you. What is cathodic treatment? This is the negative potential you can apply on your electrode surface. I told you this is the anodic treatment. Anodic treatment, just you can take a 0.5 molar sulfuric acid and then you can scan the gold surface. I told you can get like this, like oxidations of gold, reductions of gold, like this, right? 0.5 molar sulfuric acid, like in minus 0.2 volt to suppose 1.4 volt. Then you are scanning for a few times. This is the anodic treatment, because anode mainly the positive side you are. But if you apply negative potential, some maybe you can apply, you can check a gold electrode, gold disc electrode just, then you can go for the cathodic treatment just inside the sulfuric acid medium. You can go for the like negative side, or maybe you can apply some negative potential, or you can go like negative scanning, minus 0.22, suppose here you can apply like minus around 1.2 volt. So you can get like here reductions, then something like this. So this negative side treatment, that is called the cathodic treatment, also can help the kind of reconstructions of the your electrode surface, and you may get the higher activity before and after you if you check. So this is also new treatment that I am introducing now, and anionic treatment just I told you. And you have to measure like glucose or formic acid, we will get the faster electron transfer rate. Now check the activity with aging, then you will get the slower, and that can be deactivated again by sodium boride treatment, right. So this is the tuning effect. So now let us come back with one by one treatment and how your surface can be affected with different treatment. So systematically one by one treatment I will come. So like this, like you are getting the higher activity and electron becomes slower, then you will get the lower activity. This is just a schematic, and you can get the enhanced transfer rate when you apply again sodium boride. Let's come the Pantone treatment now. See, Pantone treatment, it is just a chemical mixture. It is 1.1 molar, 1.0 millimolar EDTA and 10 millimolar hydrogen peroxide mixture with 1 millimolar ferrous sulfate. This chemical mixture is called the Pantone's reagent. This Pantone's reagent, if you dip your electrode inside this reagent, just make a beaker, small beaker, make this Pantone mixture and dip your gold electrode and check with different time interval. You can see this phenomena at the beginning, just after polishing or just before Pantone treatment, you may see the AFM structure is very high, and you will get the high activity, and slowly it will decrease. So the surface becomes slowly plane. So something actually striking on your surface, right? What is that? That is something radical actually it is generating. This is a hydroxyl radical, OH dot. This hydroxyl radical generated from Pantone's reagent. This radical actually hit here, and the surface become smoother, and you can see the cyclic voltammogram. I told you last class also, if you check cyclic voltammogram, this is just kind of hydroquinone cyclic voltammogram. So we measure 0 to 0.6, this is hydroquinone. See, just before the Pantone treatment, see, so we are getting something like very high catalytic activity, right, because their oxidation peak and reduction peak, they are very close, right, they are very close, and high current you are getting. I told you, no. So if their oxidation reduction peak are very close, it means E half value, that is E half value very low, and you are getting high oxidation current, reduction current. It means your surface is highly electrocatalytically active. Now if this peak shifted, oxidation peak if shifted towards right, and reduction peak if shifted towards left, and current also decrease, right, it means your electrocatalytic activity also slowly decreasing. See, we increase the dipping time inside the Pantone's reagent, and then we measure this hydroquinone oxidations and reduction. And then we see, the peak current also decreasing and peak potential also shifting, right, slowly it is shifted, and after a quite longer time you see is almost shifted towards right, and reduction peak also shifted towards left. So E half value slowly increasing. E half value means you can remember like peak potential of the EPA means anodic peak potential plus EPC, cathodic peak potential, divided by 2, right. This is the E half value. So the E half value will increase, and every time when I am showing you some cyclic voltammeter, you see in the x axis we are showing the E versus V versus E by V versus AG cell. What is the meaning of this? So we are using which reference electrode? That is the meaning of this. So, we are using here silver chloride reference electrode, because these peak positions is highly depend on your reference electrode. If you use a hydrogen reference electrode, calomel reference electrode, then this peak position will be changed. That's why which reference electrode you are using, that you have to always mention. This is not like a very standard oxidation peak potential. It depend on your reference electrode. That's why always you have to mention when you represent a cyclic voltammogram. Always you have to mention which reference electrode you are using. So here I am using silver chloride reference electrode, and by V means here we are representing this is the as a voltage, and in the y-axis this is the current of hydroquinone in microamps unit. Okay, this clear? This cyclic voltammogram for Fenton's reagent. Okay, now I will come back again in the next class with some another treatment. Fenton treatment also again I will cover, like what is the reason of this, why the surface changing of the roughness, that I already just mentioned the hydroxy radical. Now I will come with proper reason, with proper informations, proper surface images, and we will show you more tuning method. It's very interesting, right? Many treatment methods you are learning here. So first you learn sodium borohydride treatment, that is chemical treatment, right? Today I told you the polishing, that is the mechanical polishing, mechanical. This is mechanical treatment, right? Mechanical polishing, and also you learn cathodic treatment, right? Today cathodic treatment means you are applying some negative potential or negative area, you are scanning your electrode, and also you can improve the electrocatalytic activity. And another treatment, Fenton, Fenton's reagent and its effect. So this one I will continue again in the next class. So tuning of the electrocatalytic activities, that can be done very easily, right? And this all the things can be explainable. This we can explain easily. So let's come in the next class. Thank you all. Thank you very much for this class.